Hi, my name is Brennan Proudfoot, and this is going to be a presentation on Smart or Supershell, which is an active research presentation or project under myself, Professor Dewan, and James Juszczak, a fellow master's student. Just as some background, this started as a research project under Professor Dewan, and the initial concept was a distributed shell where a user or a student could request help from an instructor who could remotely control their machine. So if a user couldn't figure out how to do an assignment, they could digitally raise their hand, and then the instructor could see that that student needs help, uh, take control of that user's shell remotely, and then once it has control, any command sent from the instructor shell, or any command in the instructor shell, will be sent over to the student shell. It will be executed in the student shell, and then the results will be sent back to the instructor so they can just help them through this process. And we did that last semester and then realized that there was a bunch of other stuff we could extend on. And so now we're adding smart features that work in an offline setting. And the offline setting is different than the online setting, as you don't need internet for the offline ones. For the online one, we had a smart setting where you could predict it would be like crowdsourced tab completion. So depending on what other users have gotten in a tab completion for a certain command, uh, you could basically get their tab completion. So if user A typed in like ls.l.f.d or /f/ blah blah blah, user B would be able to see that whenever they do our special tab complete. And our thinking was that there are some commands which require certain flags, which are kind of hard to understand just by reading the documentation. And so if we see certain users have been using certain flags, it might be helpful for other users to see that as well. Uh, but our new feature works in the offline setting, and I'll get more into that, but it's going to be called rhelp, and this is what James is working on. So rhistory is the first command that we worked on, the first thing we worked on in this new shell. And it's kind of like your regular Unix history, and then it stores the commands that you've entered. But unlike your regular history, it's way more beefed up. So it's in JSON format, and it stores a bunch of different information about your command. So it'll store what time you did your command. It'll give you the output of the command. It'll give you the standard error of the command. It'll tell you the time spent working on the command. If you're in an interactive setting, it will tell you like Vim or Pico or Nano. It'll tell you like the word count that you've written, the amount of lines you've written, the total amount of time you spent working. And also, whenever you're working on a file, it will store a copy of that file. It'll basically cache it, that file. And it includes a number of different filtering criteria like command, file name, or date. And this is kind of the backbone. Rhistory is the backbone for the rest of the features that are going to be built in this shell. So here's an example of rhistory, and here we can see we wanted the history of this file t.sh, and so the latest command written on it was vim, and we can see that we wrote one word, we added one new line, we spent 5 seconds on the working on t.sh, and we can see the date was March 27th, and we have a copy of the file as well. So rstats is built on rhistory, and it's meant to give useful stats for a particular file or assignment or directory. So for a given file or directory, we can find out the number of lines of code that you've written, the word count, the number of files that you've altered, and the total amount of time that you spent working. So we can find out your daily, weekly, and monthly stats on all of these things. So you can find out within a week the number of files you've altered, the number of lines of code you've written, just everything. And here's an example. So your weekly stats for t.sh have been 14 lines of code have been added, 30 words have been added, and you've spent 75 seconds in total. In terms of the installation, it's quite simple. You just navigate to your virtual machine. You call git clone with this repo, which is under my GitHub, and then you cd into the directory, and then you call bash install.sh, and you follow the prompts. And so the prompts is just going to be there's a user study form that you're going to need to consent to. And once you say yes to being involved in the user study, it will download all your prerequisite libraries that you need and then get everything configured for you. So all you have to do at that point is just restart VirtualBox. So exit and then vagrant SSH, and then you should be good to go. And then once you're back in, you should be in the new shell, which you can test out by using either rhistory or rstats. If neither of those gives you an error, then you're in our shell. So the user study form is what I mentioned you're going to have to consent to in the installation instruction setup. And so you're just consenting that your shell data is being collected for a user study, which is going to help with future features, which I'll go over. This is going to be rhelp. The command is going to be rhelp.
Hi, so today I'm
here
going to
is
be
a
demonstrating
demo
the
of the
features
installation
of the
instructions and then a
supershell
basic
that's
use
been
case
developed by
of
Professor Dewan and I.
doing an assignment and what rstats
My name is
can
Brennan,
do for you
and so this is a tutorial.
in that
So
use
first,
case,
navigate
or
to
the information it can
your
give, I guess,
virtual box.
and just how it's used.
So I'm just going to vagrant SSH and just copy this link because you're going to be cloning down this repository. So git clone, then wait for that to come in. This might take a bit. So there's going to be 4 files: a license file, which you don't need to worry about, a consent, which just has the consent information for this study, the actual shell itself, and then an installation script. So now it's cloned down, so let's cd into the directory, and let's run the installation script. Okay, so you can read through this consent stuff. Basically, if you say no, then you can't install it. So if you want to use it, say yes. It will install all the dependencies you need, and then just exit out of your shell. Restart it. And then you can see it's vagrant SSH $ instead of just a $. And that should be your cue that you are now in the new shell. And you can check that just by doing something like rhistory. And so I already have a history because I've used this shell before, but you probably shouldn't have this many files or this much information in your history. And so I'll go over what rhistory is and some other stuff, but just as a use case, let's look at the first programming lab done for 411. Okay, so let's get the file, which is intro.c. Intro.c. Okay, so say make dir a1. Okay, and so exercise 1 says, so change it, so now it's in centimeters. So let's say to result in centimeters. And so centimeters, you just need to adjust the, so 1 inch is 2.54 centimeters, so this should work. And then let's say gcc example1.c. Okay, so they say 2.54, 3.14. All right, that looks right to me. And then cp 1.c, example2.c. Okay, so now we also display the circumference, which is 2 times and okay, hopefully that works. So let's say GC. Okay, so now the example they give is 6.28. Okay, that also looks right. And then finally, example 3. So now CP example 3.c. Okay, so what are we looking to do? Okay, so set this while loop in. Hopefully that works. So GCC 3.c. Okay, so something went wrong. Let's see why. Equal to 0. Okay, that all looks right to me. And so now that we've completed the assignment, we can get some metadata on it. So you can say like our history, and you can see the history of all your actions. So let's go back to the beginning. We can see we made a directory, we cd'd in, and there's no real metadata for these. But so we can see, okay, vim example1.c, we can see the new word count, the number of lines we've added, and then the output. So we store a version of the file. Here, if we had had a mistake in compiling, that would have shown up in standard error, and I guess I'll show you an example of that in a second. And so we store the result of everything. So we store the result of running example 1. When we cp it, we store what example 1 is. When you change example 2, we have like the amount of seconds you've spent on it, the difference in lines, the word count difference, everything. And so that's useful because we can do things like this. Rstats d. Okay, so on this assignment, my total amount of time spent coding was 3 minutes 20 seconds. I wrote 19 lines of code, which checks out. Lines of code, not including the copies, because those technically don't count as active session. And then my word count was 61. And you can see the files I edited were example 1, 2, and 3. So if we want more specific information, we can do like rstats f example 1 dot. Okay, so we spent 1 minute, 24 seconds on that. Uh, it was 17 lines of code, added 45 words. Uh, so you just get some meta statistics about like how long you've been working, and in terms of usefulness, you can kind of track progress as you go, especially in terms of time. So you can track the amount of time you spent on a project, and it's all just kind of transparent to you. You're not setting a timer. You are just letting the shell do all the work for you. Uh, and here, so let me do a bad example. So 3.c. Then let's get rid of the semicolon here. And GCC. And then if we do our history, we can see the latest time we try and compile, we store what the standard error would be. And this won't necessarily be useful solely to you, but we're developing a system that can kind of detect when users run into errors and then help them correct from that using like a help command. So this will be useful for that. So this is just a basic demonstration of how to get your shell set up and just kind of its core functionality. Okay, thank you. That is going to be it, I think.
Okay, in terms of the features that are coming soon, there's two that we currently have on the docket, which is our help and R&do. Our help is going to be using the data that you agree to consent to give during the installation process. So we're basically going to get your shell data, and the main idea of our help is that it's crowdsourced help. So given a certain state, our help is going to attempt to predict what command needs to be executed to get you out of, or like what your next command should be. So if you're having difficulty on, uh, I guess not in assignment, if you're having difficulty in general in the shell, you feel like you're stuck, you can type in R help and it will see where you are, the past commands that you've executed, and then given what other users have done in the past, it will try and predict what the best thing to do is to get you out of your situation. And so we need data for this, which is why we're gathering your data. And R and do is much more simple, no machine learning. It's just we're going to be using the cached versions of the file that are stored in R history to allow you to basically undo changes you've made or if you've deleted a file to bring it back. And this will be very helpful for me at least because I know I tend to remove files I don't mean to remove using RM. So I feel like this will be pretty handy. And as this is a active research project, there are many different commands we could do, so if you have any ideas, please let us know. We'd love to hear them. Uh, my email is bwproud@live.unc.edu, and I would love to hear any and all ideas that you have. Thank you.